Hello, 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 hello. Am I audible? Hello. Okay. Okay. Good evening, everyone. So I am Pankaj Kapri, an NPTEL PMRF TA for this course, calculus, the basic calculus, and I'll be discussing some problems related to the content of the week second and third, and the most of the problems will be based on limits of functions. Okay, how to find limits of function, maybe left hand limit or right hand limit. Okay, so let's start with the first problem. Okay, so here we have this function which is f of x equal to sine of 1 over x, and you have to find the range of the function and determine if the function is periodic or not. Okay, so for the range of function, you know that the sine function, sine of x, always lies between +1 and -1, right? So this is less than equal to 1 and greater than equal to -1. Okay, but here our function is sine of 1 over x. Okay, so okay, so we have to just find if these values of 1 and -1 are attained or not. Okay, because if you can see that if x goes to infinity or minus infinity, then this 1 over x, that will go to 0, and sine of 0 is 0, so our function will go to 0. Okay, and if you put x is equal to 1 over, let's say, 1 over n pi or pi by 2. Okay, so first we write 2n pi by 2, which is just n pi. Just put pi over 2. Okay, so if x is 1 over pi over 2 or 1 over 3 pi over 2, then you can see that sine of 1 over x is either +1 or -1. That means the endpoints are attained, right? So the range of the function must be +1 to -1. Okay, so range of function, which is r, plus -1. Okay, so are there any question? Okay, so if there are no other questions, let's find out if this function is periodic or not. Okay, so what we mean by periodic function? So we say that a function f is periodic if there exists some real number, let's call it p in R, such that the value of the function remain unchanged when you change the input by p or multiples of p. That is, whenever you take multiple of p, the value of function does not change, right? So this is the definition of a periodic function. Okay, so like sine function is a periodic function because if you put 2 pi times any integer k, so here this k is any integer, k belongs to z, because we are taking multiples of that period pi. So this is just sine x. Okay, so that means sine x is a periodic function. It's a periodic function with period 2 pi. Okay, so the period we define as the smallest number, such smallest number p, we define it to be the period of the function. Okay, so here for us the function, the given function is sine of 1 over x. Okay, so is it periodic or not? Because the sine function is periodic, but what about sine of 1 over x? Okay, any guesses? Okay, so our claim is this function is not periodic. Okay, so why it is not periodic? So let's assume that function is periodic. Okay, yes, it is oscillating near zero. So assume that the function is periodic. That means there exists some real number r such that for every integer k, we have that function. If you just scale it by multiples of p, that is x plus pk, that must be equal to the same value of the function. Okay, okay, in general or in particular, what will happen if you put x is 1 over 2? Okay, let's then you will have f of pk plus 1 over 2 pi same as f of 1 over 2 pi. Okay, but what is a f of 1 over 2 pi is just sine of 2 pi. That means it is 0. Okay, so so we have this thing that f of pk plus 1 over 2 pi is always 0 for every integer k, whatever integer we choose. Okay, so it's always 0. Okay, now what we will do, we will choose some number integer, choose some k, let's call it k naught in z. Actually we will choose it k naught to be positive. So how we are choosing this number? We choose it in a way that the 1 over pk plus uh, this number, okay, the reciprocal of pk plus 1 over 2 pi is less than pi. Okay, like this, so that this thing lie between 0 and pi. So that we can do, right? Because if you take high enough number k, if this k becomes very large, so why this is happening? Because 1 by k goes to 0, h k goes to infinity, right? So we can choose very large k so that the 1 by k, the reciprocal, it becomes very small. Okay, so there are lots of such integers k naught, positive integers, for which this reciprocal lies between 0 and pi, and we will take one of them. Okay, now what will happen if, let's call this as x naught, 1 over, let's call x naught to be this p times k naught plus 1 over 2 pi. We call it x naught. And what will happen at x naught, the value of the function? Okay, so can anyone tell what is f of x naught? Okay, so this is some number f of x naught, because why? Because f of x naught is just f of, or let's write sine of 1 divided by x naught, but x naught is p times k naught plus 1 over 2 pi, right? Now notice that this x naught lie between pi and 0. This is positive, and that will just say that the sine of x naught must be positive. Okay, so this number must be positive, but we have seen that in this equation, first equation, that this number, this f of pk plus 1 over 2 pi, this becomes 0 for every integer. That means the equation will imply that will imply that f of x naught is also 0, and that is our contradiction, because these two things cannot hold simultaneously. Okay, so this is a contradiction, something wrong. And why this was wrong? This is wrong because of our wrong assumption. This contradiction arrived because we assumed something wrong, and that wrong thing is that function is periodic. Okay, so this contradict our assumption. Okay, this contradict our assumption, and therefore this shows that f is not periodic. Okay, so the correct option is the last one. That is, the range is between minus 1 and 1, including the endpoints, and that this function is not periodic. Okay. So any questions regarding this problem? Okay, so if there are no problems, let's move to the next question. Okay, you have to find the limit of this function, where you can see that this function is x square plus 3x plus 2 divided by 2 minus modulus of x. Okay, so this is our function, and we have to find this limit when x approaches minus 2. Okay, so that means on if you can consider some graph of the function. Okay, so then mean the graph, basically you are approaching this value of minus 2. Okay, your x is going to very close of minus 2, either from left or from right. Okay, so because we are so we can assume that our this x lies very close to minus 2 in some interval. Okay, so we'll just assume that x lies between minus 1 and minus 3. So let's assume this for timing. It doesn't matter, because ultimately x is coming near to minus 2. Okay, that means basically x is negative. Okay, so because x is negative, this mod x is just minus x, because mod is always positive. So if x is negative, then minus x is positive. Okay, so now in this case, what is our function? This is x square plus 3x plus 2 divided by 2 minus mod x, where mod x is actually minus x, so that will become plus x, right? This is x plus 2y. Okay, so this happening near under this assumption. Okay, so because of this assumption, we can write function like this, and now we can factor the numerator. So how we can write the numerator? This is x plus 1 into x plus 2 divided by x plus 2. Okay, and we are also assuming that x is not equal to minus 2, but still we can go as near to minus 2 as possible, without assuming that as x is equal to minus 2. And because x is not equal to minus 2, so this two terms get cancelled, and we will have just plus 1. Okay, so this means what is the limit? So limit x goes to minus 2 of fx is just equal to limit x goes to minus 2 of this x plus 1, which is minus 2 plus 1 right? So its limit is -1. Okay, so the first option is correct. So any questions here at this point? Okay, so let's move on to the next problem. So you have two functions f and g, and it's given that when x approaches some number a real number, the limit of the product and the difference is 3 and 2, okay, or 2 or 3 respectively. And you have to find the limit of this plus fx plus gx, okay, given that thing. So what we'll do, we'll just use this inequality or equality, the formula that if you take the square of a plus b and subtract the square of a minus b, so what you will get, right? You will get 4 times ab. So this is one identity we are going to use. So it will say that the fx plus gx, this whole square is same as fx minus gx, this whole square, plus 4 times f of x into g of x, okay? And therefore limit x goes to a of fx plus gx whole square is same as, okay, this limit and this limit. So what will be it? This is limit x goes to a fx minus gx whole square plus 4 times the limit x goes to a fx into gx, right? Now this limit is given to be 3. The limit of fx minus gx when x goes to a is 3. So when we are finding the limit of this square of this function, so that will, by algebra of limit, you can see that. Okay, so here we can say that limit x goes to a fx whole square is just same as the square of the limit. Okay. And therefore this limit is equal to 9, and the product approaches 2, so this is 8, right? So this everything is 17, and therefore this implies that again, because of the same proposition, this one, that this limit of this square is same as square of the limit, we get that limit of fx plus gx is just square root of the 17, right? Therefore the second option is correct. So any questions up to this point? Okay, so if there are no questions, let's move to the next problem. Okay, so in this problem, so you have given three functions fx, gx, and hx. So where fx is the sec times 10, right? Okay, let me write. Fx is sec x, 10x. What is gx? This is x plus cos x. And what is hx? Is x to power 4 minus 1 under root. Okay, and then now you have to find out which are odd function, which are even function, and which, so there can be some function which is neither odd nor even, so we have to find out this property. Okay, so what is an odd function? So what you will do, you just replace x by minus x and you see what happens. So if this turns out to be fx, then we say that f is even function, and if this turns out to be minus of fx, then we say that f is odd function. Okay, in general. Now for sec x, 10x, what we have? Okay, so the sec x, 10x is basically, sec x is 1 by cos x and 10x is sin x over cos x. Okay, so this is, you have sin x divided by cos square x. Okay, now if you put f of minus x, then you will have sine of minus x, which is minus of sine x, right? Because sine x is a not function, and this is remains same, right? Because it's the square of the cos, and cos is itself an even function. So this is just equal to minus of fx. That means f is odd. Okay, what about g? So g, what is g of minus x? Just replace x by minus x plus cos of minus x, which is minus x plus cos x. Okay, and this is neither equal to gx or minus of gx, right? This is not equal to gx. Why? Because gx is x plus cos x, and this is cos x minus x. And similarly, it cannot be equal to minus of gx. So g is neither odd nor even. What about hx? Let's write h of minus x, which will be same as minus x to the power 4 minus 1, which is same as x to the power 4 minus 1, and that is same as hx. Okay, so this implies that f is odd, h is even, and g is neither odd nor even. Okay, so which option should be correct? So f is odd, j is neither even nor odd, and hx is even. That means the third option must be correct. Okay, so any questions? Okay, so if there are no other questions, let's move to the next problem. Okay, so what is given here in this problem is given that when x lies between minus 1 to 1, then your function lies between x to the power 4 and x square. So there are some inequalities basically. So one is this and one is this, depending on where x lies. Okay, and it says that, so for which values of c, that this limit is guaranteed to be exist by sandwich theorem. Okay, by sandwich theorem, not by any other means. So what is sandwich theorem? It says that if you have function sandwich between two functions, sandwich between, that mean I mean by, if this inequality hold for these three functions, that hx is less than equal to fx less than equal to gx, for every x in the domain, whatever these functions have their domain, the common domain, or you can say that in some interval where you want to find the limit. So we can write that it is some delta in neighborhood of c, where we can remove c also. It can be a diluted neighborhood. Okay, and the limit x going to c, hx is same as limit x going to c of gx. Okay, so the lower the hx and gx, they have same limit when x approaches c, and this will imply that the limit of x approaching c of fx is also is, this limit exists, and this is equal to, so let's say that this limit is equal to L, and then the function fx is limit exists, and this is equal to L. Okay, so this is a sandwich theorem. Okay, so the sandwich theorem, the statement is this. And now we have been given that our function x to the power 4 less than equal to, so this inequality hold whenever x lies between 1 and minus 1. Otherwise, another inequality hold when x is either greater than 1 or x is less than minus 1. Okay, so that means we can say that whenever mod x is less than 1, and that is equivalent to mod x to be greater than 1. Okay, so and you want to know for which values of c you can conclude that the limit of this function exists when x approaches c using sandwich theorem. So using sandwich theorem, what do you get? You can get only these information, that limit x goes to c x to the power 4 is less than equal to limit x goes to c fx is less than equal to limit x goes to c x square. Okay, and in the second case, just the reverse of this inequality. Okay, so let me write that also, that limit x goes to c. So either this hold or so this is square. Okay, now for sandwich theorem, we want that this limit and this limit must be equal. Okay, okay. To apply sandwich theorem, we must have, we should have, or we must have, or we want that these limits must be equal when x approaches c of x square 4, and again when x approaches to c of x square. Okay, now when okay, so left hand limit, this just becomes c to the power 4, and the right, and on the right hand side the limit becomes c square. Okay, so you can apply sandwich theorem only when, or only for those values of c for which c to the power 4 is equal to c square. Okay, so this implies that c square times c square minus 1 must be 0. Okay, so this will imply that c is either 0, 1, or minus 1. Okay, so for only these three values, you can say that the limits of the function exist using the sandwich theorem. Okay, so the third option is correct. Okay, so any questions till now? I'll just wait for 5 minutes. If you have any questions, then you can ask. Okay, so if there are no questions, let me move to the next problem. The sixth question. Okay, so this is, I think, a different kind of question where we don't have to find the limit, but we will be using the limit to find the answers. So you have to find the domain and range of the functions. Okay, so what is our function? So fx is twice of sine 3x plus pi minus 1. Okay, so what is the domain? So you can see that this function defined for every value of x. So there is no problem because the sine function defined for every value of x. So 3x plus 5 is also defined for every value of x. Or you can see that this function is just composition of some functions. Okay, so what are those functions? So you can write f1 of x as 3x plus 5, f2 of x as 2 sine x minus 1, and then you can write f as the composition of f2 compose f1, right? Okay, so now the f, you can see to find out the domain, you have to see for which values of x the function is defined. Okay, for which real numbers this function has some value, well defined meaning. Okay, so you can see that there is no problem with defining this function for any value of x. So this domain of this function, domain of f. Okay, so in this case, actually, because the f is composition of f2 and f1, this is same as the domain of f1. And what is the domain of f1? This function, you can see that it's just the linear function 3x plus 5, 3x plus pi, defined for every value of x. So this is just real number r, set of all real numbers. Okay, now we have to find the range of the function. Okay, so now for the range of function, you know that the sin x lies between 1 and -1. Okay, so 1 is the highest value of sin x and -1 is the lowest value of sin x. Okay, so what will happen? So at which point can x achieve its highest value? Okay, so there are lots of points where x can achieve its highest value. This you can find out that, but we don't need do that explicit calculation, because you know that this function defined for every value of x, and sine attains its heights, sine lies between -1 and 1. So the function can lie between 2 minus 1 and 2 times -1 minus 1. Okay, so this just imply that the function lie between -3 and 1. Okay, so therefore, what is the range? The range of f is just the closed interval -3 1. Okay, so the first answer is correct. Okay, so the real number we also write like this in this as an interval. Okay, so any questions till now? Okay, I think there are no questions. So let's move to the next problem. So some limit is given. What is that limit? The limit of 4 minus fx divided by x when x goes to 0. Okay, so this limit is exists and it is equal to 1. Okay, so now notice that for this particular function, what is that function? That is gx is equal to 4 minus fx divided by x. Okay, and for this function the denominator goes to 0 and still the limit is a real number. So the limit of gx exists even though the denominator is going to 0 and x approaches 0. Okay, that means that the limit when x goes to 0 of the numerator 4 minus fx, this must be 0. Okay, because if this limit is non-zero, then the limit of gx must be infinity. Okay, it should not exist, and this just implied that the limit of function fx when x approaches 0 must be 4. Okay, so the third option is correct. Any questions? Let's move to the next problem. Okay, so again a limit is given, and which limit is given? That limit x goes to 0. Okay, so it's x goes to 4, x times the limit x goes to 0. Okay, so the limit x goes to 0 of gx, this limit exists and it is given to be 2. Okay, now notice that it asks the what is the limit of gx when x goes to 0. Okay, so we are asked this limit, and you can see that if this limit is not a finite number. Okay, so if this limit x goes to 0 of gx, this limit does not exist. Okay, so if this limit does not exist, or this limit exists but is infinite, and that way we also say that it doesn't exist basically. But okay, let's say that this limit does not belong to R. Okay, it's not a real number. Then the limit x goes to 4 of x times this thing, which is x tends to 0 gx, this should not exist, right? This is does not exist also. Okay. Now, therefore, because this limit is 2, that means it exists. We have that this implies that the limit x goes to 0 of gx must belong to R. It should be a real number. Okay. So therefore, let's call this real number L. And now we are given that limit x goes to 4, L times x, it's 2. Then this must imply that because this is just a real number times x, so this is just a identity function or a linear function. So this limit is 4 times L. Okay. And that is 2. And this will give us that L must be half. Okay. So that means the second option here is correct. So this second option is correct here. So any questions till now? Okay, let's move to the next problem now. Okay, so here again we have same kind of question. We have to find the limit of this product of fx gx, and given that the limit of fx plus gx and fx minus gx exist. Okay. Okay, so where were we? So last time we used this equality or identity that a plus b whole square minus a minus b whole square is same as 4 times ab, right? So again we will use the same inequality for the functions, and we apply the limit on both sides. So the 4 times limit x goes to a, where a is some constant, of fx times gx must be equal to the limit x goes to a fx plus gx this whole square minus the limit x goes to a fx minus gx whole square. Okay. Now this limit, okay, so we this property of limit I have told before also, that limit x goes to a of a function which square you are taking will be same as you first find the limit of the function and then take the square of the limit. Okay. So whenever both side makes sense, you can do that. And in our case, is given that the sum of this function has limit 3 and the difference has limit -1. Okay. So this is just 3 square minus 1 whole square, which is 9 plus or -1. Okay, so which is equal to 8. Now because here we have this 4, so we can divide by 4 on both sides, and that will imply that limit of x goes to a of this product fx times gx is just equal to 8 by 4, which is 2. So are there any questions? You can just ask by unmuting yourself. Assignment 4, question 1. I don't understand here. So what do you want to say?
Sir,
If
see the problem,
which
assignment 4.
which problem?
Assign, first problem. Backslash is there. No,
Okay.
fourth assignment. Fourth assignment. I'm doing
Fourth.
fourth assignment. Assignment number 4.
From this particular problem sheet which I am discussing here.
No, sir.
Which one then?
Current. I just want to know what does backslash means. Is it negation?
Backslash means this division, right? See here, we have written this 1 by x. This is so 1 over this x means we are dividing by x.
No, sir. Please see the problem first.
So it's a backslash you are saying.
Yes, sir. Please look the problem.
Just wait for some time.
Okay, sir.
So assignment 4 and first problem.
Yes, sir. First problem. Backslash means does not mean.
Okay, okay. So the set symbol. Okay, I understand.
Yes, sir. I was confused there.
Okay, so this is just a set notation. So when we write this a minus b, so this is minus
Yes, sir.
basically. In other words, you have seen somewhere this notation also, that minus. We are
Ne-
removing a part
you
of the
mean
set.
negation?
No,
Negation.
not negation is just minus. Okay,
Okay,
so in
sir.
the Venn
That
diagram,
means
you can so you can understand it like that in the Venn diagram. So if this is a and then another is b set b, so you can understand that this is intersection, right?
yes, sir.
A intersection b,
Yes, sir.
and this part we say that it is a minus b.
Okay.
Okay, a minus b, because from the
Okay.
a we have removed everything b, the everything
Okay, sir.
all elements from the b we have removed from a. That means from
Okay, sir.
a we are removing the intersection part, and this
Okay,
we
sir.
call a minus b, and then here you have this part you will call it b minus a.
Okay, sir.
Okay,
Okay. Thank you,
so
sir.
instead of minus, because the minus symbol we usually write for numbers when you are subtracting numbers, so some people they don't like to put minus between sets, and for
Okay.
sets they write this symbol, this backslash, which you were saying for
Okay.
the minus set, removing a part of
Yes.
b from a. Okay,
ठीक. ठीक. Okay, sir.
is just removing a intersection b. This is same as you can remove a intersection b also
Okay.
from a. All are
Okay.
same.
Thank you, sir.
Or you can also take a intersection b complement. From the outside of b you are taking which is common with a, right? The outside part, the outside you are taking. So b complement means the outside of b, and you are taking from outside element lies inside a. Okay,
Okay, sir.
okay, so let's move to the next problem. This one, the 10th problem. So you have to find the limit of the function, where function is just straightforward. It's a rational function. Okay, so what is our function? Rational function is a polynomial divided by another polynomial. X square minus 4x plus 4. Okay, so this is a polynomial, and then you divide this polynomial by another polynomial which is degree 3. So x cube, and this is 5x square. Okay, so there is a little bit typo. This is 5x square plus 5x square, and then you will have minus 14x. Okay, and you have to find the limit when x goes to 0. Okay, so what you can do, you can divide both numerator and denominator by let's say something x square. Okay, you can divide by x square. So if you divide by x square, or okay, so okay, we are just finding limit at x equal to 0. Okay, let's not do that. Okay, first observe that this numerator you can write as x minus 2 whole square, right? This is the square of the x minus 2. And from the denominator you can take x common, and in the bracket you will have x square plus 5x minus 14. Okay, so can we do something here? Can we factorize this x square 5x minus 14, or that will not help? That may help, right? Let's see if that helps. X, so you can write x minus 7 into x plus 2. So is this correct? This is x square plus 2x minus 7x. So I think this should be plus and this should be minus. X minus 2. Okay, now you can cancel 1 x minus 2. That is fine because we are near 0. Okay, so you can just assume that x is not equal to 2, and then you're left with x minus 2 divided by x into x plus 7. We have to find limit x goes to 0, x minus 2 divided by x times x plus 7. Okay, so we can see that there is a extra term in the denominator x. So the denominator has degree 2 and the numerator has degree 1. So if you put x equal to 0, so okay, so you can simply write this as limit x goes to 0 of 1 by x and into the limit x goes to 0 of x minus 2 divided by x plus 7. Okay, now notice that this limit exists. Okay, so what is this limit? You just put x equal to 0 and you will have minus 2 by 7. So this is just equal to minus 2 by 7, and you have limit x goes to 0 of 1 by x. Okay, now does this limit exist? The limit, so you can see that this limit doesn't exist. Why? Because we are going near 0. So if x is negative, so if you are approaching from the left, so if x is less than 0, then the limit x goes to 0 of 1 by x, so that we sometimes denote as minus. So this minus just says that x is negative, or we are approaching x from the left hand side. So this limit is just equal to minus infinity, because when x becomes very small, this 1 over x just becomes infinite. Okay, and when x is positive, the limit x goes to 0, which we call 0 plus, because we are approaching 0 from the right hand side, and x is positive, this limit just become plus infinity. Okay, so you can see that in the graph also, the graph of this function looks like this. Okay, so you can see that when you go near 0, the functional value becomes very large, and if you go from left hand side, then you can see that the functional value becomes very small. Okay, so this implies that the limit does not exist. So limit x tends to 0 of fx does not exist. So the limit does not exist. The last option is correct here. So any questions? Okay, so let's move to the next problem. I think there are no questions. Okay, so what is this limit should be? Cos x minus 1 divided by x when x approaches to infinity. Okay, so limit x goes to infinity, 1 minus cos x divided by x. So can someone suggest what should we do? Anyone? Oh, okay. So notice that these trigonometric function like cos x, they always lie between 1 and -1. Okay. So what will happen with 1 minus cos x? So okay, let's do it step by step. You just take minus sign. Okay, so cos x. So this will just become, okay, so the minus of cos x, if you put this minus, then the inequality reverses and you will have this will be greater than -1. And so it still lies between 1 and -1. And then you add 1 in both sides. So this will become 2. So 1 minus cos x lies between 0 and 2. Okay. So if you put a modulus sign, then you get that this is less than equal to 2 by mod x, and here you have 0. Okay. So now or if you don't put a modulus sign, then this is okay, because okay, so if you don't want to put a modulus sign, then also this inequality holds, but when x is positive, right? Because if x is negative, then the inequality will get reversed. Okay, so you can apply, you can actually put a mod so that you don't have to deal with if x, two cases when x is positive and x is negative. Okay, so let's put modulus. Now this, because of this inequality, you can notice that the limit when x goes to infinity. Okay, I think we can assume that x is positive because x is going to infinity. So we are very near to infinity. That means x is very large. Okay, x is going to infinity means x is becoming very large. So when can x become very large? That means it must be positive. Okay, so we can, that much we can assume that. And if you are assuming that, then you can leave the modulus sign also. Okay, it's up to you. So even in this case, you can see that this limit is becoming 0. Okay, now you can use the sandwich theorem. The limit x going to infinity of the 0 function, which is 0. Again, this limit is lie between 2 by x, which is again 0. So this limit is 0. Now, because this left hand side function has limit 0, right hand side also function has limit 0 when x approaches infinity. That means by sandwich theorem, okay, so let me remove this symbol. So by the sandwich theorem, what we'll have, the limit x going to infinity 1 minus cos x divided by x becomes 0, right? So any questions? We have used the sandwich theorem or sandwich rule. Okay, the second option is correct here. Okay, let's move to the next problem if there are no questions. Okay, so we have this function sin x divided by something box of x. Okay, so this box is called greatest integer function. Okay, so greatest integer means this, when you put some value of x, it gives the greatest integer, which greatest integer such that that integer is less than equal to x. Okay, so the mod x is give you n which is less than equal to x such that n is largest integer belongs to z. This is the property of the greatest integer function. This graph looks like this. If you see, if you put any number between 0 and 1, so when you put 1, then it will give 1. But if you put something less than 0 or less than 1 between 0 0 and 1, then it will give you 0, right? So the box of half, right? This box of half, because this 0 0.5, it is 0, because the greatest integer function always gives you some integer, and the largest integer which is less than x, that is less than half, is 0. Okay, that means this graph looks like this. So here this is something open, because at 1 it will lies at 1. Okay, and then like this, open and then close at 2. So graph is like this. Okay. Okay, so if values of x are between 1 and -1, or -1 and 0, so it gives -1. Okay, so like this, it graphs goes on, and we have to find the limit of this function when x tends to infinity of sin x divided by this box of x. Okay, so what do? We will again use sandwich theorem. Okay, so sin x by this box x will lie between 1 over box x and this -1 over again boxes, because the sine function lies between 1 and -1. Okay, now the limiting value when x goes to infinity of 1 over box x, this thing. Okay, so we must have this inequality between the limits. Okay, so if x becomes very large, then this box x also become very large. Therefore the 1 over box x is very small. Okay, that means that the limit of x goes to infinity 1 over this box x is 0. Okay, now because this limit is 0 and this limit is also 0, again by sandwich theorem, limit x goes to infinity of sin x divided by box x is also 0. Okay, the second option is correct here. So if there are any questions, then you can ask. Okay, so let's move to the next problem if there are no questions. Okay, so for next 3 4 questions, 3 4 means from 4 to 7. If you see a number here 4, you will see this number 4 5 6 7. So for next 4 questions, we'll always assume that this is given. Okay, so what is given for this function f? Whenever you approach x from the right 0 from the right hand side, the limit is a, and if you approach 0 from the left hand side, then limit is b. Okay, that is, if your x is less than 0 and x still approaches 0, then the limit of your function is a, oh no, it's b. And so these numbers are real numbers. So if x is positive and x goes to 0, that means you are approaching 0 from the right hand side, and this limit is given to be a. Okay, so both these limits are finite numbers, they belongs to r. Okay, so these are not infinite limits, these are finite limits, they are real numbers. And then you have to find limits of these kind of functions. Okay, so we will see that we'll get these a lot of problems. 3 4 problems will be based on these kind of functions where you have some composition. Okay, so this function is just a composition. Okay, so f of x cube minus x, this is our function. You can call it some different function gx. Okay, but you can see that this function is a composition. How? Because you can, if you take hx to be x cube minus x, then this is just f composition h of x, right? This is it. Okay, so that means that g is a composition of two functions where f and h. Okay, so if you want to find out the limit of this function when x approaches 0, so you can see that it's approaching from the right hand side, that is x is positive. So what we'll do, we will do a change of variable. So let's see how we do this change of variable. So let's assume that x cube minus x is t. This is our new variable. X was our old variable. And notice that because x is approaching from plus, 0 from plus means from the right hand side, that is x is positive and x is approaching 0. Okay. So we can assume that x lies, so we can assume that x lies between 1 and 0. Okay, so x is positive, but still I want to control the value of x. Okay, so I, because at the end x has to become as small as possible, x goes to 0. Okay, so I can just assume that x lies between 0 and 1. Okay, so when x lies between 0 and 1, you can see that the cube of the function is always less than x. Okay, the cube of x is always less than x, and this is always positive. Okay, so because the cube of this function is always less than x, this implies that x cube minus x is less than 0. Okay, so that is t. So our t is less than 0, and when x approaches 0, t also approaches 0, right? So if, so you can see that we are just saying that this is our hx. So t is our hx, right? This is h function hx. So we are first finding the limit of h. Okay, so when x approaches 0, then t also approaches 0. But notice that t is negative. Okay, so that means we can write that if x approaches 0 from right hand side, t must approach 0 from left hand side because t is negative. Okay, so now this limit which we want to find out, the limit when x approaches from right hand side of f of x cube minus x, this is just same as the limit when t approaches from minus of f of t. Okay, so that means in the composition we have taken the limit of h. This limit we have already taken. Now we are taking the limit of f. Okay, but we have to change, we have to see from where these variables are going to 0, from right hand side or from left hand side. So in this case, this h is, the limit of h is 0 when x goes to 0, but this limiting thing happening from the left hand side. Okay, so when x is positive, t is negative. Basically that means that. And now it's given that, what is this limit? It is given that when t approaches from the left, the limit of the function is b, right? The limit of f is b if t approaches from the left. Okay, so that means our original limit must be b. That is the third option is correct here. Okay, so any problems, any questions regarding this problem?
No, sir.
Okay, so again let's move to the next problem. So this is again the same kind of problem, but still now x is approaching from the left hand side. Okay, so x is less than 0 and x approaches to 0, and we again take t to be x cube minus x. Okay, so it's the same problem, the same limit we have to find, but when x approaches 0 from the left hand side. Okay, and we have seen that if x is negative, so we just assume that x lies between 0 and minus 1. Okay, so if x lies between 0 and minus 1, what happens with t? What happens with cube of x? This will be greater than x, right? And also less than 0. Okay, so this implies that x cube minus x is positive. Okay, so initially in the previous problem, when x was positive, t was negative. Here x is negative, so t must be positive. It's the same thing. Okay, or you can see here, you can follow the same arguments, similar arguments, and you can see that as x approaches 0 from the left hand side, we have that t approaches to 0 from the right hand side. Okay, so therefore the limit where x approaches to 0 from the negative minus f of x cube minus x, this is same as limit t approaches 0 from the positive side of f of t, which is a, right? This is given to be a, that we assumed, right? For the next 3-4 problem, that the limit of function is a when you approach 0 from the right hand side, and this limit is b when you approach 0 from the left hand side. Okay, so here the second option is correct. Okay, now we have this another problem which is like similar problem. Instead of x cube minus x, you have x square minus x to the power 4. So what will happen now? Okay, so x is approaching from right hand side. Okay, that is, we can assume that x is positive, and actually x lies between 0 and 1. So this we are assuming that x lies between 0 and 1, and we assume that t is x square minus x to the power 4. Okay, so what will happen with x square minus x to the power 4 when x approaches 0 from right hand side? So where will t will go? Okay, you can see that when x approaches 0, t also approaches to 0, but from which side, that we have to find. So what should be the sign of t? Okay, so if x is positive, what should t be, positive or negative? Can anyone tell? So x cube power 4 must be less than x square, right? Because x lies between 0 and 1. So if you take high powers, then the numbers will become smaller. Okay, so if you increase the power, the numbers becomes small. Okay, that means that x square minus x to the power 4 becomes positive. Okay, so when x approaches from the right hand side, t also approaches from the right hand side, and therefore the limit x approaches from the right hand side. Okay, so in this problem we are finding, yeah, limit from right hand side of f of x to the power x square minus x to the power 4 is same as limit x goes to, or no, we are changing the variable. So instead of x, we have t, which go again from approaches from the right hand side of f of t. And what is this limit from the right? From the right, we have assumed that this limit is a, right? What was our assumption? Our assumption was from the right, the limit is a. Okay, the second option is correct here. Now the same thing goes for the next problem, which just says that find the limit of the same function, but from the left hand side, when x approaches 0 from the left hand side. Okay, so x approaches 0 minus, so therefore we can assume that x lies between 0 and 1. Okay, now again x lies between 0 and 1. Okay, no, we are not assuming, because x is negative. Since x approaches from the left hand side, we will assume that x is negative and lies between -1 and 0. Okay, but you can see that x square will always positive, and x to the power 4 is also positive, even though x lies between -1 and 0. Even though x is negative, the square, because we are taking even powers, so x square and x to the power 4 both are positive, and therefore Again, higher powers must lead to smaller values. So x square 4 must be less than x square. And that will imply that t, which we are taking x square minus x to the power 4, this must be positive. Okay. And therefore, the limit, if x goes to 0 from the left hand side of f of x square minus x to the power 4, that must be same as the limit t approaches from the left hand side, no, right hand side. Why? Because t is positive. Even though x is negative, t is positive, and this is f of t. So this is again a, right? Okay, so again a. So the second option is, again, second option is correct. Okay. So it doesn't matter from where this x approaches 0, from left hand side or right hand side, the limit will always be a. That means limits are equal. But in the previous problem, when we were dealing with x cube minus x, f of x cube minus x, in the left hand side we get limit a, but on the right hand side we get limit b. That means the limit will exist if and only if a is equal to b. Okay, so we always say that limit exists if and only if limits are equal. Right hand limit and left hand limits are equal. Okay. Okay, so the next problem, you have to find this limit when x approaches 0. Okay. So what is our function? This is sine x. Okay, this is not sine x, this is sine of 1 minus cos x. Sine of 1 minus cos x divided by x. Okay. So assume that x is non-zero. Okay, and what we will do, we will write this function sine of 1 minus cos x divided by 1 minus cos x into 1 minus cos x divided by x. Now note that we have already find out this limit when x approaches 0, right? This was one of the previous problem which we have already find out that this limit is 0 when x approaches 0. And for this particular part, we will make a change of variable. Okay, what kind of change of variable? We'll put t is equal to 1 minus cos x. Okay, and we notice that if x approaches to 0, then t approaches to 0 also, right? Because cos of 0 is 1. Okay, so if x approaches to 0, then t also approaches to 0, and therefore the limit x approaching to 0 of fx is same as the limit t approaching to 0 of sin t divided by t into the limit x approaching to 0 of 1 minus cos x divided by x. Okay, now this limit is 0 and this limit is 1. So these are standard limits. 1 into 0, which is 0. Okay, so the first option is correct. Okay, any questions till now? Okay, let's move to the next problem if there are no questions. Okay, so here you have to find this limit of this function, which is sine of x square minus x divided by x. What is our function? This is sine of x square minus x divided by x, right? And we further assume that x is non-zero, so that the denominator is well defined. The function is well defined. Okay, so here also we will use the same trick which we have used earlier, where instead of x square minus x, we had 1 minus cos x. But we will do, because we have already assumed that x is non-zero, we can divide by x square minus x. Okay, but there is a problem, because the denominator can still become 0 at 1, right? Because if you put 1, then the denominator is 0. This thing becomes 0. So because ultimately we are taking limit at x goes to, as x goes to 0, so what we will do, we'll assume that x is not equal to 1. Okay, so x is neither equal to 0 nor equal to 1. So that we can assume. And then we will have x square minus x divided by x. Okay, so and then we will make a change of variable again. So t is x square minus x, and t goes to 0 as x goes to 0, right? So if x becomes very small, then t also becomes very small, because t is just x times x minus 1. Yes, okay. And sign is will also remain same, and therefore the limit as x goes to 0 of fx is same as limit x goes to 0. So we are making a change of variable, so let's write t goes to 0 for this first function. T goes to 0 of sin t divided by t into the limit x goes to 0 x into x minus 1 divided by x, right? So but we can just cancel these two things. Okay, so you can notice that x square minus x is same as x into x minus 1. Okay, so now this limit is 1, and this second limit is minus 1, so the product is minus 1. Okay, so what should be the correct option? Okay, so this option is wrong because the limit is minus 1. This is also wrong, limit is minus 1. This is also wrong, limit is minus 1. And the last option says that this limit is a non-zero real number and minus 1 is non-zero, right? It's not 0. So that means the last option must be correct. So any question till now? I'll just wait 2 minutes. If there are any questions, then you can ask. Okay, so if there are no questions, let's move to the next problem. So this is 19th problem, right? Okay, so you can see that this says that sine of 1 divided by x minus 1. Okay, so what is our function? It is square root x square plus x minus 2, and then we have sine 1 over x minus 1, right? Okay, and we have to find limit when x approaches to minus 1. Okay, we have to investigate this limit x goes to minus 1, and no, it says that x goes to 1 from the right hand side, not minus 1. X goes to 1 from left hand side of fx. So what that means? That means that x is smaller than 1, and we can assume that it's lies between 0 and 1. Okay, so x is approaching 1 from the left hand side. So we can assume that x is lies between 0 and 1. Okay. So that means in particular x is not equal to 1. Therefore, this denominator is well defined, right? This function is well defined. But let's see what about this square root? Does it well defined or not? Okay, because the square root of a negative number we don't define. So let's factor this thing, x square plus x minus 2. So how can we factor it? You can see that we can write this as, so can we write this as this product? Okay, yes, that is correct. Okay, so x square plus x minus 2 just factors like this. This is equal to x minus 1 into x plus 2. Okay, now notice that since x lies between 0 and 1, x minus 1 is negative. Okay, so x minus 1 is negative. That means, and what about x plus 2? Okay, so you can just follow this inequality. So x plus 2 lies between 2 and 3, right? Because x lies between 0 and 1. So if you add 2, then you'll have x plus 2 lies between 2 and 3. Okay, and they will these two will imply that this product is less than 0, right? The product of a positive and negative number is always negative. And therefore the square root of x square plus x minus 2 is not defined. The square root is not defined. Okay, so because the function is not defined, or the function is not defined near minus 1 or on the left of minus 1. Okay, so in particular the fx does not define. So instead of this thing you can write that fx is not defined on the left of minus 1, and therefore the limit cannot exist. X tend to 1 minus of fx, this limit does not exist, right? Because the function is not defined. This limit does not exist. Okay, the fourth option is correct here. So any questions till now? Okay, so let's move to the next problem because there are no questions. How many questions we have left? We have already dealt with 19 problems. Then we have 20, 21, 22. Oh, I think there is a problem with the numbering. So 20, 21, then we should have 22, but it's again 20, 21. So how many problems we have in total? So this is 1, 2, 3, 4, 5, 6. So we have 6 problems. Okay. Let's do this problem. We have to find this limit when x approaches 0 from the left hand side. Okay. So we have to let's first simplify the function. What is the function? This is root 6 minus 5x square plus 11x plus 6, again under root, and divided by x. Okay, so what we will do, we'll divide and multiply, or we'll multiply in the denominator and numerator by this factor 0 root 6 plus 5x square plus 11x plus 6, and the same factor. So this is called something rationalization. Okay, but it may not be rationalizing, but it is rationalizing the numerator at least, but not in denominator. Okay, so in the numerator we will have a minus b into a plus b situation. That means the numerator you have 6 minus 5x square plus 11x plus 6. Okay. And in the numerator you have x in bracket root 6 plus 5x square plus 11x plus 6, again under root. Okay, so now you can see that this 6 will cancel with this 6 because we have a negative sign, and you can take x common, and therefore in the bracket you will leave left with 5x plus 11 with a negative sign, right? And in the denominator you have x root 6 plus root of 5x square plus 11x plus 6. Okay, so now we can write this as 5x plus 11. So we'll cancel minus x from the numerator and denominator, assuming that it is non-zero. So root 6 plus 5x square plus 11x plus 6. Okay, so we assume that x is non-zero. So this is the simplification of our function. And now notice that we are approaching x from the left hand side. Okay, so limit x approaching 0 from the left hand side of fx. Okay, so you put x instead of x you can put 0, and because you are approaching from left hand side, okay, so what you can do, instead of x you can put minus t. Okay, so when x approaches 0 from the left, the t approaches 0 from the right hand side. Okay, and instead of x you can put minus t, and now this will become 5t plus 11. Your function becomes this root 6 plus under root 5t square minus 11t plus 6, right? Because instead of x we are putting minus t. So what is this limit? We just put 0 instead of t, and the limit is 11 divided by root 6 plus root 6. Okay, I think there was no need to put but we just wanted to make sure that the under root this does not become negative. Okay, because then this square root will not be defined. Okay, so this is just 11 divided by 2 root 6, which you can write by doing again rationalization. 11 root 6 divided by 12. Okay, so there is some problem. Oh, this is minus. Okay, this was everything is the minus sign was outside of this bracket. So this is 5t minus 11, right? Okay. Okay, so finally the limit is minus 11 root 6 by 12. Okay, so the first option is correct. Okay, that's why I was wondering why I'm getting a plus sign, because the correct option is the first one. Okay, so any questions till now? Yes. So someone has already written that substitution will not change the sign of 11. Yes. Okay. Okay. So let's move to the next problem. I think there are no questions. So Okay, so we again have this bracket or box function, and okay, so we can so x is given between minus infinity to plus infinity, but certainly we cannot assume that x is zero, right? Because if x is zero, then this denominator will have problem. So let's not assume that x is zero. Okay, so what is our function? This is some sine x divided by the modulus of sine plus cos. Modulus of sine x, modulus of cos x into the box of x, and we assume that x is non-zero. Okay, and what we have to do, we have to find the limit of the function when x going to infinity of this fx. Okay, so what we can do, okay, so what we will do, we'll apply sandwich theorem. So this product, okay, note that our function, which is this, if you put a modulus sign, then this is less than equal to, okay, so we just assume that x is positive. So instead of x non-zero, assume that x is positive, okay, because we are finding the limit when x approaches to infinity. So we can assume that x is very large. That means x is, we can in particular assume that x is positive. Okay, so when x is positive, still, so this is greater than equal to zero, but this is sine mod of sine x, and you just forget that cos x was there. So if you remove cos x, then you will just left with sine x into the box x. Okay, now notice that they will cancel. So basically this is just equal to 1 over mod x. Okay, so you can just prove that this number, this function lies between minus 1 and 1. Okay, in particular, when you take a modulus sign, then our function fx, the mod lies between 0 and 1 over mod x. Okay, and therefore now you can note that the limit x goes to infinity of 1 over mod x is also 0, right? Because when x becomes large, 1 by mod x or 1 by box x becomes 0. Okay, and therefore by Sandwich theorem, okay, so what will we get by Sandwich theorem? Okay, so there is one technical detail here. So you can have by Sandwich theorem the limit when x goes to infinity of the modulus of the function becoming 0. Okay, so from Sandwich theorem we will get that the modulus of function has limit 0 when x goes to infinity, but this will also imply that the limit when x goes to infinity of the function is also 0. Okay, you can verify this is also actually a property of limit, that if modulus goes to 0, then the function also goes to 0. Okay, if modulus of the function goes to 0, then function itself goes to 0. And this fact, this particular implication is true only when the value of the limit is 0. Okay, this will not work for any non-zero value of the limit. Okay, so again the correct option must be the second one. Okay, so this must be wrong here. Okay, so correct option is the second one, B. Okay, let's move to the next problem. Now, again, for next four problems, we'll have this assume this condition holds. Okay, so these are same kind of problems which we have already discussed, and we are again doing that. Okay, so that you will not have any problems when solving your assignments. So we have to make a change of variable. Okay, so we have to find the limit when x goes to 0 from right of f, or instead of f we have a g this time, g of x minus root x. Okay, we want to find this limit. Okay, so because x is approaching 0 from the positive or right hand side, so we just assume that x lies between 0 and 1. Okay, now because x lies between 0 and 1, so if you make a change of variable by taking t as x minus root x, now you want to find the sign of this t, right? Now notice that if x lies between 0 and 1, then the square root, what happens with the square root? Okay, so you can notice the graph of the square root function. It so it is going to infinity, right? And the y equal to x line is like this, and they intersect when x becomes 1. Okay, why? Because root x is 1, or root 1 is 1. So when you your values of x lie between this interval, the open 0 1 interval, that means the root function is less than the x. Okay, so if x lies between 1 and 0, then the root x must be greater than, okay, x is less than root x. Okay, so this just says that x minus root x is negative. Okay, if x lies between 0 and 1, then x minus root x is negative, and therefore the limit when x goes to 0 from the right hand side of this g x minus root x. Okay, so this is same as the limit t goes to 0 from the left hand side, okay, of g of t, right? And what is this limit? From the left hand side, limit is given to be a, right? This, the limit of gx when x approaches 0 from left hand side is a. That means this limit is a. Okay, so second option is correct. So any questions?
Not understand, sir.
What what are you saying?
Graph, sir, graph.
Yes, graph. What about the graph?
X 0 7 0 क्लोज रहना रहेगा सर इक्वल टू 0
Yes, I am
x
taking, yes, I am taking x between 0 and 1. Okay,
0 इक्वल टू
0 equal to, yes, 0 equal to,
ब्रैकेट में रहेगा ना सर 0
जीरो ब्रैकेट में रहेगा, क्या मतलब इसका?
जीरो इंक्लूड करेंगे सर, लेस देन इक्वल।
यहाँ पे
या सर,
ओके, सो
रूट अंडर एक्स, एक्स ग्रेटर देन जीरो ना होगा सर?
हाँ, रूट एक्स तभी तो डिफाइंड होगा अगर एक्स सी रूट एक्स एक्स इक्वल टू जीरो के लिए भी डिफाइंड है, बट इट डजेंट मैटर इफ यू आर टेकिंग द लिमिट, देन इवन इफ at that particular point where you are taking the limit, if the function is not defined, then it doesn't matter. So you can just assume that the function may not be defined at the value of the limit, at which point you are taking the limit. Okay, so it might happen that in general, that your graph, let's say you are taking limit at some point a. Okay, you want to take the limit of the function at x when x approaches to a. So it might happen that the function is not defined at a, right? It can be like the function on the right hand side is like this, and on the left hand side it is like this. Okay, so the value of the function may not be defined, so we are not defining. Okay, or we can define value of the function, let's say here in between. Okay, so on the
ओके
left hand
सर,
side, let's say it's 1, on the right hand side, let's say it's 2, and we are defining at f equal to a is 3 by 2. Okay, at this point somewhere 3 by 2. Okay, so even the this, so the value of the function is will not create anything, will not contribute anything with the limit. Okay, so even in this case with the graph for which I have drawn, if you take limit when x goes to a from the left of this function, this will just 1. Okay, and if you take limit if x goes to a from the right, then this limit is 2. So it doesn't matter if the function is defined at a or not. Okay, for limit it doesn't matter. So f of a can be anything. Okay, so it can be 3 by 2 or some 4 or some minus 1 0. The the function value at a particular point does not matter when you are finding the limits. Okay, because you are constantly changing your values of x in that neighborhood of a, right? You are approaching a, but you may not go till a. Okay, you are going as close as possible to a, but x may not be equal to a. Okay, so even though the root x function defined at 0, but still I am assuming that x is positive. Okay, because we don't know about g, right? And also notice that here x minus root x, which is t. So if you put x equal to 0, then at x equal to 0, t also becomes 0, right? But we don't know if g of 0 is defined or not. Okay, so that's why we just exclude 0 from the domain. Okay, we don't know, we don't have any information about g. That is another region. It might happen that g is defined at 0. In that case you can include 0, but the inclusion or exclusion of the 0 at which you are finding the limit will not make any contribution towards the limit. Okay, so should we move to the next problem? Okay, so you are asking some other problem, assignment 4 question 1. Okay, so this is just symbol of set. Okay, so these are symbols of set, right? This is not an interval. So if there are these symbol, that means, and if there are some values, let's say 0 1 minus 1, this just represents a set. Okay, this is just a set. Okay, so this set contains only three numbers, 0 1 and minus 1. Okay, so this is not an interval, this is just a set with three. points. Okay, so let's move to the next problem. Again, this is again same kind of problem. Okay, so here we again put t equal to x to the power 5 minus x cube, and because x approaching 0 from the left hand side, assume that x lies between 0 and minus 1. Okay, so we are assuming that x is negative. Okay, so what will happen when x lies between minus 1 and 0? What about x to the power 5 and x to the power 3? Okay, so you can verify that x to the power 5 will be bigger than x to the power 3, and everything will be negative. So that is the case here, right? When you take higher powers of a number which lies between 0 and 1 or minus 1 and 0, so it will go closer to 0 very fast, right? If the higher powers will make the function go to 0 very faster. Okay, so even though x cube will also go to 0 if x approaches to 0, and x to the power 5 will also approaches to 0 when x approaches to 0, but because 5 has higher power, x to the power 5 will approach to 0 very faster than x cube. Okay, so you can verify that this inequality holds. Okay, so conversely you can also verify it when assuming that x is positive. Okay, so you can assume that x lies between 0 and 1, then you will have this thing that x to the power 5 is less than x cube. Now instead of x you can put minus t. Okay, now the minus t lie between, no, because x lies between 0 and 1, then t lie between 0 and minus 1. Okay, and you will have, because x is minus t, so minus t to the power 5 is less than minus t cube, which is again minus t to the power 5 is less than minus t cube, and when you remove the sign you will have t to the power 5 is greater than t to the power 3. Okay, so this is the region. Okay, so this is some separate calculations, and we were taking t to be x to the power 5 minus x cube, right? And x between 0 and minus 1. Okay, so as x approaches to 0 from the left, t also approaches to 0 but also from the left, right? Because no, it approaches from the right, right? Why? Because x to the power 5 is greater than x3 in this case. Okay, and therefore the limit x goes to 0 from the left of, no, g of x to the power 5 minus x cube is same as limit the t goes to 0 from the plus of g of t. And from the right, what we have assumed? From the right, we have assumed that the function has limit equal to b. This limit is b, so the third option is correct here. Okay, so let's move to the next problem. Again, it's the same kind of problem, but you can assume here t to be equal to x minus x times root x. Okay, so and because limit is from the right hand side, assume that x lies between 0 and 1. Okay, now because x lies between 0 and 1, this will just imply that the higher powers, that means the root x times root x, which is x to the power 3 by 2, right? The higher power is less than x. Okay, so this inequality will hold, and this will imply that x minus x to the power 3 by 2 or x root x is positive. Okay, therefore the limit x going to 0 from the right hand side of g of x minus x root x is same as the limit x going, or now we are changing the variable, so t going from 0, t goes to 0 from the right of gt, which is again b, right? That we have assumed that it is b. Yes, we have assumed that it is b. Therefore, in this case also the third option is correct. Okay, so let's move to the next problem, the last problem of this session, I think. Yes, I think there are lots of problems. Okay, so you have to find limit x going to 0 from left of g of x square minus mod x cube. Okay, now because you are approaching 0 from the left, the same trick you can apply here, that you can assume that x lies between 0 and minus 1. Okay, now because x is negative, the mod x becomes minus x, right? Let's take t to be x square minus mod x cube, but because x is negative, the mod x becomes minus x, and therefore this will become x square plus x cube. Okay, but x is negative, okay, so let's see what happens when x lies between minus 1 and 0. So x cube will be bigger than x square, right? So this inequality will hold. And what about the sign? If you add x square on both sides, let's say you are adding x square plus x square is less than x square plus x cube, and that is less than x square. Okay, we are adding x square everywhere, and this becomes 2x square, which is positive. So that means x square plus x cube just becomes positive. Okay, and therefore the limit x goes to 0 minus of g of x square minus mod x cube is equal to limit t goes to 0 from the positive side, because x square plus x cube is positive, g of t, and this is again b, right? The third option is correct. Okay, so
सर
here,
दूसरा मेथड है क्या सर
किसका दूसरा मेथड?
इसी क्वेश्चन का सर
इस क्वेश्चन में like you have to open the brackets, right? The modulus sign. So assuming that x is negative, the modulus just becomes minus of x. So I think that is the obvious thing to do है, यहाँ पे यही कर सकते हैं, और इसके अलावा or okay, so if you want to do something else, so okay, so don't open the modulus. Okay, so what you can do that is, we are assuming that this is x cube minus mod x square. So what you can do, so we are assuming that x lie between 0 and minus 1, so x is negative. So now x is negative, that means the minus x becomes positive, right? Minus x lie between 0 and 1. Okay, so if minus x lies between 0 and 1, so you can somehow write this minus of minus x cube minus mod x square, and now because this is minus of minus x cube minus mod x square, so I think this will just complicate the things. Okay, so because x is negative, what is mod x? Mod x is just same as minus x, right? Here x is negative, therefore mod x is same as minus x. So here you can just write this as mod x cube minus mod x square. Okay, now you can take minus sign common, you can just write as mod x cube plus mod x square. Now you can obviously see that because mod x is always greater than equal to 0, when x approaches to 0 minus, so are we getting something different? So this just gives us that when x approaches to 0 from the left hand side, t approaches to 0 also from the left hand side, because this is just negative of m modulus, or am wrong. I think we are doing some mistake here.
Mod x cube.
Yes, because mod x is equal to minus x, right? So what is mod x cube? So mod x cube is same as minus x cube, which is just minus of x cube. So instead of minus x cube, I am writing mod x cube. I think I am doing something wrong. Okay. Okay. Still, we cannot say that this t is negative. We have to again determine the sign, right? Because there is a, I think there is some problem with this calculation. I think this will just complicate the matter. So the whenever you see the modulus, it's best to just remove the modulus sign, assuming that the what is the sign of your x. So I think this is just complicating the matter. Okay, so this is the I think
Okay, sir.
the
Next
best
question,
approach.
sir.
Okay. Okay, so here we just end our live session, and thank you everyone for joining. And then we will meet next week with the another set of problems based on the that week lectures. Okay.
पीपीटी शेयर कर दीजिए सर.
हाँ, ये हम मैं शेयर कर दूंगा, बट एक्चुअली NPTEL से ही शेयर होगा. So this will be shared by NPTEL. Okay, so I'll just upload it from the
लिंक शेयर
in
कर
the
दीजिए
Google
सर.
Drive.
गूगल ड्राइव
Yes,
लिंक
yes.
सर.
Uh, okay, so let me find the link of my folder, drive folder, and from there you can get the recorded videos also and this PDF. Okay, so this is the link of my Google Drive folder where I will upload this PDF file. Okay, so now only the previous week's PDF file is there. So I will upload it after we will just end our session. Okay, so you'll get it in this folder, and this is shared publicly, so there will be no problem. Okay, so thank you everyone for joining the session, and we will meet next time, next week. Okay, at the same time.